Exam Excellence 3 for Year 12s, looking at circular motion. So the object shown in Figure 2 is travelling clockwise on a smooth surface or in a horizontal circle with a radius of r, clockwise, so it's going this way actually. Select which arrow would best show the velocity of an object at the instant in Figure 2. So at this very instant, the velocity is going to be at a tangent, so it's going to be c. Select which arrow best shows the acceleration. Well, the acceleration is in the same direction as the force, and the force is into the centre of the circle, so it's going to be E. No, that's the question we just did. If the force acting on the object shown were to suddenly stop at the instant, what direction would the object continue to move? Well, it'll go along this path here. That's its instantaneous velocity there, so that's the path that it will take. So C. A child stands at the edge of a rotating merry-go-round in a playground. To keep the child moving in a circular path, the merry-go-round is applying force on the child. Select the statement that best describes the reaction to this force. So what forces are acting on this kid? Well, his weight is acting down and the normal is acting up. Neither of those have any effect on this centripetal force that's acting inwards. The friction of his shoes and his hands, though, is going to be opposing. So it's going to be the thing that affects it. Like the normal, it's not having any effect. So the normal reaction of the force on the child, no. The static friction exerted by the child on the merry-go-round, yeah, that's the reaction to that force. If there was no centripetal force in, he wouldn't be feeling that frictional force. I'm going for B. Force of gravity, no, it's this way. The weight, that is the force of gravity, so B. An object performing horizontal circular motion takes 10 complete revolutions in a time of 8 seconds. Period of rotation. So the period is the time for one rotation. So how many rotations does it do? It does 10 in 8 seconds. So I want to know how long it takes to do one. So I'm going to divide the 8 seconds by the 10. 0.8 seconds per revolution. So this would be seconds rev. So period, how many seconds per revolution? Yes, I've done it the right way round. And that makes sense, doesn't it? If it's doing 10 laps in 8 seconds, it's going to be less than a second for the period, for the time of 1 second, 1 lap. Righto, so D. All right, over here into the short answer. We've got a car. It's trying to go 90 kilometres an hour around a corner, radius 80 metres. The road is wet and the friction is 65% of the car's weight. So first of all, this is in kilometres an hour. We've got to convert that to metres per second. So you can do it from first principles. 90 kilometres times 1,000 divided by 1 hour times 60 minutes times 60 seconds and get it like that. Or if you happen to remember it, you can just straight up divide it by 3.6. So doing that is the same as dividing by 3.6. So it's 25 metres per second. The weight of the car is 1,800 times 9.8 and the friction is 65% of that. So that's where I've got that from. For the car to safely round the corner, the centripetal force and the frictional force have to be the same. Otherwise, it would be sliding out or inwards. So centripetal force, mv squared on r. We're using the velocity in metres per second, and we get that. So the centripetal force is greater than the frictional force. So it's too fast. Righto, over here we go. It wants to know what's the maximum speed. So the maximum speed is going to be when the centripetal force is equal to the frictional force, and we know what that is. We've already got the frictional force from over here. We're just going to substitute in and find what v squared is. That's in metres per second, and it asked it in kilometres per hour. So instead of dividing by 3.6, we're going to multiply by 3.6. Little check. Does that sound sensible? If 90 was too fast, 81 sounds like a reasonable answer. If it was 102 or 10, then we've made a mistake somewhere. Oh, and this one here, I had a little check too. It's too fast. Part B suggests that too fast is the correct answer here because it says what's the maximum speed you could go. So it's a bit of a leading question, this part A. Right, this is the experiment that we conducted one afternoon, or tried to conduct. 7.09 seconds for the robber stopper of mass 50 grams, convert that to kilograms, to do 10 revolutions. But they've forgotten to calculate the suspended mass. To record, sorry. Determine this mass. So we know it's 7.09 seconds to do 10 revolutions. So that means the period, 7.09 seconds to do 10 revolutions, 0.709 seconds per revolution. Then I can use this formula, V equals 2 pi r on t, to get the velocity, 6.65 meters per second. I know that the centripetal force is equal to the tension in this string, and that tension is coming from this weight here. So the centripetal force equals the tension, and it's M2. This is M2. G, put that into mv squared on r equals, so I've just substituted that for Fc, but I also know that it equals Ft. Bit of rearrangement, and the mass is 0.3 kilograms, so 300 grams. And again, does that sound sensible? Well, yeah, that sounds sensible according to the experiment.